pretty big deal because a lot of the workloads are fairly spiky.
Can do it line by line.
We definitely have more tricks.
Super awesome because very easy to use.
We think the next phase of Databricks and the next phase of also just data and AI platforms in general is to make it dramatically easier for everybody.
Hey folks, so today I'm with Youssef and we have a special guest with us, Reynold Xin. Thank you so much for being here with us today, Reynold.
Hey, thanks for the invite and glad to be here.
Yeah, so Reynold, you are one of the co-founder of Databricks, now working as chief architect at Databricks. You also kind of co-found Apache Spark, so worked a lot on distributed system. I think you worked a lot on Photon, the new kind of Databricks Spark engine, which is rewritten in Vector C++ to provide faster execution. You also used to be one of the top 1 Apache Spark contributor. I think it's not the case anymore, so which makes us wonder, what are you working on these days?
Yeah, so many years ago, I think maybe in the beginning of Databricks, probably up until 2016, 2017, I was writing a lot of code on the open source Apache Spark project. I was basically, other than sleep, eat, I was writing code. And then I kind of stopped because I had to spend a lot of my energy elsewhere also. I still spend a lot of time on Spark, but less so on sort of writing code. And finally, sort of a couple other people maybe surpassed me last year in terms of number of commits. I spent most of my time now actually basically managing and driving a whole bunch of our different products in I would say, the foundational data layer. This includes Databricks SQL, our engine, our storage efforts, also our latest AI BI efforts. So a lot of different things that I'm spending my time on. So it's less so on any individual given projects, but on sort of the whole collection of them that's in the data space.
Okay, and Reynold, so today we want to focus on the data warehousing.
Okay.
And can you share a bit about data warehousing journey from how it began with Spark jobs and now supporting these low latency interactive queries?
Yeah, so one thing that's pretty interesting is we were kind of convinced by our customers that we should be going to data warehousing. Databricks SQL now, I think it's about 2.5 years since it's a GA, and we've disclosed publicly it's north of $400 million sort of ARR, annual recurring revenue, and making it one of the fastest sort of enterprise software in sort of maybe growth. That's certainly in Databricks history, but probably just in general. So north of 400 million ARR, making it potentially one of the fastest growing enterprise software out there, certainly in Databricks history. One of the thing that's really interesting is we didn't actually sit down and say, hey, let's build a data warehouse. It was actually about 4 or 5 years ago, almost at this point, that when we look at, we're doing a lot of data science on, hey, what are our customers doing in terms of our workloads? And we realized, hey, there's actually some non-trivial amount of usage on running BI workloads, and in particular also SQL workloads on top of Databricks. And this despite us making it very, very difficult to even discover how to connect BI tools to Databricks. And we obfuscated the docs quite a bit because we felt, hey, Databricks simply weren't great for those workloads in the past. So we didn't want a lot of customers using it and then coming back and say, hey, how come it doesn't work that well? But despite that, we're seeing sort of substantial uptake in that usage. So we started interviewing a lot of them and asked them, hey, why are you doing this? Why are you connecting your BI tools? We never really, none of the solution architects were even pushing for that. And all the customers told us a very similar message, which is, hey, I'm already using Databricks and that was before we pushed for the term Lakehouse, so they weren't using the term Lakehouse yet. We're already using Databricks to generate a lot of our data sets. We are doing our ingest from using Databricks for most of our data sets, and we're doing the transformations on them. So the data sets are already there. Yes, we often export them into like a Redshift or some other cloud data warehouse for the BI workloads, but we are not going to duplicate all of our data sets into a cloud data warehouse from Databricks. And every once in a while, somebody needs access to a column or a data set that's simply not available in the data warehouse. They're designed for BI. So we give them access to Databricks. That's how it happened. So to us, that was a pretty sort of important product management opportunity, which is, hey, there's a very natural fit for running BI workloads on top of Databricks, on top of a Lakehouse. As a matter of fact, after we spent time thinking about it, we actually think we could do this even better than cloud data warehouses can on this BI workloads and the SQL workloads. We can do it cheaper, we can do it faster, and we can certainly do it. And the intrinsic value of that, having access to your, so almost all of your data in a way that's centrally governed, is very appealing. So we sort of double down on it. We build a pretty sizable team. We sort of revamp a lot of things to make it work much better. Like today, what we have, I think it's a very compelling offering that's great performance for both very long-running queries, complex workloads, and for very short queries as well. So that's DB SQL.
And what was what were the main changes which really made a difference, from running jobs to doing low latency? Like, was it Photon? Was it more like
Yeah, there are so many. Obviously, there's real big ones. Photon was very key in that. It was a complete revamp of our engine, and it's an MPP engine. And then there's also Unity Catalog itself is very important because when it's just a few data engineers building very complex pipelines, you don't necessarily need a lot of governance. But once it's enterprise-wide and want to give it out to a lot of teams, analysts, governance become extremely important. And serverless was also a pretty key change. Being able to spin up compute in seconds and have them readily available is a pretty big deal because a lot of the workloads are fairly spiky. And being able to basically satisfy the elastic compute demand is pretty important. Yeah. But there's tens of thousands of very small changes that have gone in. Even just in the case of latency, Photon was a very big deal, but we had this latency tiger team whose job was nothing but just let's try to shave off latency as much as possible regardless of where it is in the stack. And they've done so many little changes that adds up to a pretty sizable gain.
And every year we see engines becoming simpler and more performant. Where are we now? Are we reaching a plateau, or do we have more tricks to speed up the computation?
Yeah, we definitely have more tricks. There are so many things we want to do that we haven't been able to get to, and I think we'll have easily the next 5 years cut out for us. Potentially much longer, but I could very easily see, hey, here's a roadmap for the next 5 years when it comes to engine performance point of view. I think there's a lot that would go into even lower latency. I think we could probably squeeze out another 100%. So basically make things even 2x faster. There will be a lot of hard work, as you know. So the more, the faster you make it, the harder it is to make it even faster. It was relatively trivial 10 years ago to beat Hadoop by 100x. It got a little bit harder to beat Spark itself by 10x, and it certainly got harder to beat the better Spark with Photon, and now we have to beat the current version of Photon. But yeah, I think there's a lot. One pretty important thing is it has to do with simplicity also, is AI. There are a lot of knobs in sort of complex performance engineering, and many of those knobs, I think, maybe not all of them, but I think vast majority of them will be able to do away with AI. And having machine learning models actually learn based on your actual workload and make predictions based on, hey, what's the best parameter to set. And I think that would still also get us a next one.
So when we say AI, are you thinking about things like the query plan and knowing, kind of what to join first based on some rules and that the AI would have learned, things like that?
Yeah, certainly. The query optimizer is one sort of component I think can be disrupted by AI. For those of you that maybe have a little bit more knowledge of the internals of a database or a data warehouse, The query optimizer is the one that decides, that basically decides how you should actually execute a specific query. And historically, query optimizers are very dumb. They're actually very complicated, but in practice, very dumb. It's wrong all the time. I think I made this joke 2 years ago at Data and AI Summit about, hey, if query optimizers are often wrong, like 10 orders or 6 orders of magnitude wrong. If any human being in the attendance is wrong 6 order of magnitude times, they'll be fired. But if it's a query optimizer is wrong, we'll have to learn how to deal with it. I think because how wrong it can be and how easy it is for it to be wrong, this is actually a great opportunity for machine learning models to come in and actually do better. This is a little bit in state-of-the-art research land. Nobody have cracked the code. There's no sort of well-established literature on here's how do you do it. I think we're at bleeding edge, and we could potentially be the place to solve this problem, because we are one, if not the largest data platform that runs all, like we see the largest amount of queries, and we have the largest amount of data just by the nature of sort of the data engineering side. We could actually leveraging all those workloads to determine, hey, how can we actually build an AI-based query optimizer rather than the traditional sort of cost-based optimizers.
Yeah, that's interesting. I was about to ask, because you mentioned you have like at least a 5 years roadmap of optimization, but is it mainly kind of known tricks from, kind of the standard database world that we just want to reapply to warehouse, or is it brand new R&D that we really have to redesign?
Yeah, I would say it's a combination of both. There are certainly some traditional tricks that are relatively widely known that we haven't even done yet. Often the way we do them is depending on the workload, because I think many traditional tricks, they were optimizing for a highly optimized data layout that customers have spent a lot of time doing. But in practice, we don't actually see that. If you sort of read a Sigma or VLDB paper, which is the most popular academic conferences for databases, a lot of optimization about, hey, here's like when you have an integer column is very dense, how do you join the integer column with another maybe sparse integer column? In practice, customers don't encode data in integers and think super clearly about here's how you model the data. They just dump the data in, often in strings, in JSON, in whatever, the most horribly inefficient encoding is possible. So we didn't spend as much time applying a lot of the more traditional sort of techniques. They're well known, and many of them would make TPC-H pretty fast. And that's why when you look at Databricks, we actually are probably not the most efficient when running just TPC-H benchmarks. We're much more efficient running customer workloads, but we're not necessarily the most efficient running TPC-H, because TPC-H is a very old benchmark that's been exploited to death by all the databases. But we spent more time thinking, hey, if all the data are strings, even for dates and years, customers don't use integers, how do we make those fast? So there's a lot of that. There's certainly a lot of traditional things, like when it comes to, hey, if I do spend the time to create a super well-modeled schema, how can I squeeze the most performance out of it? I think there's a lot of things we can do there. There's a lot more we're trying to think out of the box every day on, hey, given this type of workloads, they are not very well documented in academic literature because people don't have access to workloads. What other techniques we can do to actually make them faster?
And what about kind of AI functions, but for end users? So I'm thinking about, max, sum, average, but the same logic but applied to text. Like, can you give me an average of the text of the full column, and the AI is going to do some summarize operation behind the scenes? Is it something we are exploring?
Yeah, we already ship a whole bunch of those, as a matter of fact, that pretty much any function, any model you can call, like any model you set up in our foundational model API layer as part of the Mosaic AI stack, you could call it from Databricks SQL. So you can do anything, summarizations, the sentiment detection. We build in a whole bunch of them, but you can also just give the arbitrary prompt of saying,
So
hey,
yeah. I mean, you're right. So we can do it line by line. But I'm thinking about, I've seen a lot of use cases where you have like many rows and you want to do kind of aggregation operation on top of that. And it's tricky to do.
Aggregation as in
like I don't know, based on all the reviews, extract the top 10 reviews having negative, like a negative feedback, for example. So you have to read everything, kind of do some aggregation, and locally analyze the text and get you back the final results.
Yeah. I think one thing that's the beauty of all this SQL functions is making it very easy to combine unstructured data analysis with structured analysis, because you could actually do on a line-by-line basis, extract sentiment or extract how well written a specific thing is and assign a score, and then you can actually sort it just using vanilla SQL. Or you can sort of run aggregations based on some sort of, let's say you assign a sentiment score. But one of the other thing we're doing, and some of this are still cooking, some of this are already available, is want to make it a very common sort of type of workload people really want to do, is to be able to get prediction. Revenue prediction, cost prediction, usage prediction, all kind of prediction into the future. We already have those prediction functions in DBC code that you can basically call to plot a time series. But we are also adding we're gonna make it substantially easier to leverage AI BI, but that's a different topic. And I think that's when it will become super powerful, when we can really think about how do we holistically design the entire stack vertically, versus just working on, hey, how do I make the data warehouse itself or the engine itself super great, or how do I make a separate BI tool super great.
Yeah. And it feels recently that the market is re-implementing old-fashioned transactional databases, concepts like we have liquid clustering, autostats, storage optimization, stored procedures. Are we going to fully catch up with the traditional SQL databases at some point, with integrity constraints, isolation levels?
Yeah, I think, but the one correction, I think the question makes a lot of sense. There's just one correction. Liquid doesn't exist anywhere else. Liquid clustering is actually one of those things. Because you ask me, hey, are we just implementing known tricks? Or are we inventing new things? Liquid is actually a brand new invention that I don't believe any database in the past have had it. And clustering, everybody has it. But traditional clustering has a lot of flaws, including typically they have this major minor sort of column effect, which is the first column is specified have basically the biggest impact, and the second column have substantially less. It only matter if you sort of if all data have the same first column. Liquid's beauty and the brilliance in it is it doesn't matter. It would actually balance out regardless of where the position the column specified in. And it's also super dynamic. It makes it, you don't have to worry about sort of skew on one part. And so like, for example, if you have a very popular key, Liquid solved all those problems. And Liquid's like not a catch-up per se. But the theme of our question is really about, hey, will we maybe say 5 years from now, will we have all the features from traditional data warehouse and databases in the Lakehouse? I think the question is approximately yes. What we want to do is, there's a lot of good ideas in traditional databases and no reason not to have them. I think transactions is a great concept. I do think there are better ways to build data pipelines with more rigor without transactions, basically leveraging idempotency. But I think transactions is a pretty useful concept. A lot of people are getting used to. We should definitely have it. The integrity constraints, we already have it in many places. I think many of those are great concepts that a lot of workloads depend on. We want to make those workloads very easy to migrate to a Lakehouse. So if we don't have them yet, we'll work on them. We very likely support them. There might be minor, the reason I said approximate yes, there might be some that every system, every database have some feature they'll add it, and everybody is like, why do we even have this in the first place? Nobody wants to use it. It's super difficult to understand. I don't think we'll get to those. But for all the major ones that people depend on and are useful, we definitely should have them. And I see no fundamental reason why we can't have them. At some point, I think the Lakehouse should be a superset of any data warehouses.
Yeah. And so, like now, we still need to have the kind of real-time database. I'm thinking about the MySQL, Postgre, this kind of tech. And then you have to always copy everything, dump everything into Lakehouse to do your analytics. Do you think at some point we'll come up with some system, being able to do both, and you just have the data at one place and you can do low latency? I'm thinking, mobile phone application level, and on top of that also like the full data warehouse stuff. Do you think it's doable?
Yeah, I think it's doable. But there's a term for this, which is HTAP databases. But if I slice and dice it, I'm of the opinion that HTAP databases in a specific form is not super useful, and I'll explain that. I think there are many. So the world is largely separated into, hey, here's like the analytics stack, which is slowly changing, and your runs of maybe you touch every query touches a lot of data and are somewhat slow. Like a fast analytical query might be 500 milliseconds. A slow one could be days, right? And then the other side, the OLTP databases, online transaction processing databases. This is like the Postgres, MySQL. Updates are super frequent. You can run maybe 1 million updates a second, and slow, like queries are run in like 10 milliseconds. And a second query is considered long running. I think there are some fundamental sort of trade-off between when you design the system to go one and another. So in an absolute sense, some trade-off is not really possible to design one system that runs super well for both. But my theory with system design is trade-offs usually exist at the boundary, like at the frontier of the optimization space. That's when you really have to make trade-offs. But vast majority of software systems on the planet are super inefficient. Efficiency, while important goal, is often not the number one thing you want to optimize for. You want to make sure you can maintain the software. You want to make sure the software is understandable. So we're not at the frontier in terms of efficiency. We're not too far away, but we're not right there. So there's often things you can do without trade-offs. Like the classic trade-off, for example, in many systems is latency versus throughput. But in practice, you can improve both latency and throughput at the same time for vast majority of systems out there. But the reason I said I'm not a believer in HTAP system in a very specific, but HTAP stands for hybrid transaction analytical processing, is I think when people think about HTAP, they often think about, hey, I have a database and I start my OLTP database, and then I directly run analytics against the OLTP data. The reason I don't think that is a great idea is in practice, most analytical workloads, you will want a slightly different schema from the OLTP workload. That's why the process of CDC exists. Like people do this, so change data capture, they actually encode the data slightly differently when they want to do analytics. It's because the type of queries they're running are fairly different. So if you need to change the data anyway, that step or that duplication of data doesn't seem to be an issue. Now, why do you care about having exactly the same system under the hood? I think today you do care because there's many things that are kind of very difficult. First of all, it's very difficult to get data from a OLTP database into a data lake or a data warehouse. It requires a proper data engineering team in many cases at scale. I think that problem needs to go away in the future. The other one is, hey, maybe your OLTP database and your transactional workloads or your analytical workloads have very different capabilities. So now when you deal with two different systems, you are constantly switching back and forth between, hey, this is the set of capabilities of my analytical side, and this is a set of capabilities of my OLTP side. And something overlap, they all run more or less SQL, but then everything's different. They have different data types, they have different sort of capabilities, some have integrity constraints, some don't. And that made it very difficult for people to switch from one to another. So I think in the future, we should be able to make that difference dramatically smaller and to make it sort of lower the cognitive overhead.
I think it really makes sense. One of the common use cases I've seen is when you start creating data apps and you want to have a kind of a mix of everything. But I think the point you make really makes sense. If you keep two systems but make it super easy to synchronize them, and maybe with things like Archeon and all these, like Flow Connect setup, then you're right. I don't see any reason not to have to
And don't forget about the Lakehouse Federation, which is sometimes for dimension, like the dimension tables often are the ones that people don't change. And as a result, you could just do real-time lookups. Those you could actually either federate, and I think we'll come up with newer technologies in the future and newer product offerings that you don't even have to worry about it. Basically, we should be able to blend the line as much as possible, even though underlying architecture might be quite a bit different.
Yeah, for sure. You could have everything into Unity catalog, and it could be like two systems under the hood. All right.
And what are the challenges that you anticipate regarding balancing the complexity while you do the integration of like the latest features to make sure that you will maintain ease of use and keeps having good performance for end users?
So we don't always do sort of the best job, but we are really trying hard internally, and often you'll see actually in our internal mailing list, some engineering team come up with a new way of doing things. They say, hey, here's like a config to turn it on, and I'll turn it off. And we'll be okay with that during a preview period because they want to be able to get feedback. But you almost inevitably see the pushback from some other engineering team or from the founder saying, hey, we should do no nub. Basically, we think the next phase of Databricks and the next phase of also just data and AI platforms in general is to make it dramatically easier for everybody. Yes, it's very important to make things more efficient because all of these workloads are super large and they consume a lot of compute cycles. And we'll continue to be doing that. But really to truly democratize the data and AI, we have to make it substantially easier to use. And that is the key. And ease of use refers to a very holistic ease of use. It's not just, hey, do you have a drag and drop UI, or do you have this thing in every language? But it really means, hey, when you consider the end-to-end user journey, how much does the user have to think, and what are the number of maybe users out there that can benefit from a system without having to call maybe the most technical users for help. So in a way, I would actually rank ease of use higher than performance. John Elsterhout, a very well-known professor who used to be at Berkeley and went to Stanford in the last decade, was famously quoted for saying, I think the biggest performance improvement of them all is when the systems go from not working to working. So that's what I was referring to. If we could get the system to be easier to use, and now it can benefit for more users. To those users, we're getting the biggest performance improvement of them all for them.
And do you see, so talking about new user, do you see new user still doing SQL as a data analyst? Are we seeing maybe more and more data analysts doing kind of analyst and SQL and warehouse operation using Python, maybe also using LLM to help them, go faster?
Yeah, all of them. I think so on one hand, I think we'll expand into people that don't even know SQL. I think the true democratization is how do we enable every user out there, regardless of technical sophistication, so they can get some value out of data. Now, of course, the ones that have absolutely no maybe sort of data foundation is not going to be ingesting a petabyte of data and then processing that. But there's a lot of data analysis tasks they want to do every day. They're not necessarily satisfied by Excel or Google spreadsheet that we should be able to help them in the future. But coming back to the Python side, I think we talk a lot about DB-SQL and about SQL here. If you talk to 15 years ago, me, I would tell you, hey, all data analysis are basically done in SQL. But having seen through how much have world or changed the complexity of the type of analysis that all the organizations been doing, and also the rigor people want to bring, I think Python is becoming as important, if not even more important than SQL. And a lot of it has to do with sort of the complexity of the task people are trying to accomplish, but also bringing engineering to data engineering. If you think about data processing, and yes, SQL is actually pretty powerful. It's a Turing complete language. You can do a lot of things. You could probably even approximate pretty much all Python in SQL. You probably implement a Python interpreter in SQL. Very slow one. But the SQL is extremely difficult to test. SQL is very difficult to modularize. If you think about the last 30 years or 40 years, there's a discipline called software engineering. We don't talk about it as much these days, but there are a set of techniques that we have figured out to use to build robust applications with software engineering. And these are CI/CD, abstractions, there's a lot of them, IDEs and all of this. But when it comes to data processing, even though we have the term data engineering, if you look at it, when it's using SQL, most of those techniques for sort of serious application like software engineering don't apply. Like, how do you unit test SQL? Good luck. It's very difficult to define, like to modularize SQL. Yes, you can create views, you have a common table sub-expressions, but those are very clunky compared with classes, functions in sort of Python, right? So I think there's a lot about complexity and being able to handle more complex tasks, but I think maybe the primary beauty of Python is, hey, it's a real programming language in which all the software engineering toolkits come for free. And by providing the first-class Python API, basically the PySpark API is de facto standard for data processing at this point, you can actually do very serious data engineering. You can collaborate with a larger number of people. You can build robust pipelines. You can test it. You can very easily do rollouts, staging, dev prod. These are things, it's still possible, and there are frameworks out there like dbt that help you with that, but are much more difficult, much more unnatural with SQL. And that's, I think, one of the true power of Python.
And I have a question on the AI BI before we close. I think it was unveiled recently during the Data and AI Summit. So AI BI had two options. We have, let's say, AI BI Genie, which is super awesome because very easy to use. I think it's one of the easiest products to use in Databricks. And we have dashboards, which is also, I think, a revamped version infused with AI, because even me, who is very bad when it comes to building dashboards, I'm able now to build dashboards. And I keep discussing with Chao and Miranda, but I want to have your own vision about where do you see AI BI dashboards, I don't know, for the next 2 years. What's your vision for...
Just the dashboard side or just AI BI in general?
Let's say dashboards.
Yeah, I think we'll continue making the dashboards a lot more. So dashboards are a reasonably well-defined product. And there's a lot of BI tools out there that are more or less basically dashboard tools. Sometimes people ask me, what's the difference between BI and dashboards? Like, they're very similar. But maybe when you have enough feature sets, you become a BI tool. When you don't have cross-filtering and all those features, you're a dashboard. I think there's a long tail of features we'll continue being sort of implementing, so this would become more and more compelling offering. Where I am very excited about, obviously, is the ability to combine it with Genie and to infuse more and more of the AI capabilities into this. And I think we'll have new use cases that, like today, people think about AI capabilities in BI tools. They think mostly as of, hey, I call it bolt-on AI, which is what Ken used that term at the Data and AI Summit keynote. They basically think about how do I add a co-pilot to my dashboard to help me build dashboards. But I think ultimately, business intelligence is about sort of getting insights out of data, and dashboard is a form factor for that. So the part I'm really most excited about is not only just adding sort of AI capabilities or a co-pilot-like capabilities to a dashboard, but really, hey, how do we think from first principles, and what are the product surface areas that we are building that we haven't even imagined yet, that will help people get insights out of data, leveraging AI. Like I think if we just take a slightly longer term horizon, the rise of the internet or the rise of mobile phone enable a lot of use cases people never even thought about before those. Like yes, everybody thought I would be able to call people anywhere I wanted to. That was the first sort of use case that people can think of. And I think it's very similar to co-pilots or sort of assistants for dashboards or sort of text to this. But over time, a lot of use cases showed up, like taking a picture, geotag it, upload it to Instagram, social network. All of this new use case showed up that people, like none of us had imagined when mobile phone first came out. I think there will be a lot of this, and we'll spend a lot of time talking to customers, learning how we can help them and think about some creative ways of building this in the AI BI portfolio.
Yeah, that makes sense. So Reynolds, when last time when we asked you to record the session with us, you asked us to raise the bar and to double down the number of subscribers. So now we are at 3K. Yeah. What if we hit 6K? So can you help us get another co-founder?
Sure, absolutely. I'll wrestle Patrick or somebody into this. Once you get to 6K.
So this person will be the third person since we already interviewed Mate. Now it's your turn. So thank you so much, Reynolds.
No problem. Thanks for having me.
Thank you, Reynold.
Bye.